Good evening, guys. Welcome once again. Welcome to Physics Hub. Oh, my heart rate is saying 125. ये घड़ी खराब हो गया है. Is everything all right? We can start our session on this Sunday test. Good evening, Harry. Can you hear me? Am I live or not? गुड इवनिंग नेहा. आप लोग सुन पा रहे हैं मुझे? कैन यू हियर मी? गुड इवनिंग नेहा. ओके, so I think everything is all right. So every Sunday we'll be taking a test, that is Sunday test. So first Sunday test we have already taken, and the solution manuals although I have uploaded, but today in this video we'll be discussing all the problems. This is the Sunday test. This was conducted on आज कितना तारीख है भाई? आज है 22, मतलब 18 तारीख को लिया था ना, on 18th. And this was the syllabus. So mathematical physics 1. So all the questions which we will be discussing will be based on this syllabus from mathematical methods of physics: dimensional analysis, vector analysis, and matrices. From dimensional analysis there are 3 problems, from vector 5, and from I think 6, here 6 questions. So total 15 questions are there in this set, and this Sunday test are the part of our test series. So if you have not enrolled for our test series, you can enroll for this CSIR-NET December 2024 test series. So all the tests which are there in the test series, that will be there. In addition to that, every Sunday you will be getting a Sunday test. So you will be getting 12 full length tests, 2 half syllabus tests, 3 tri-unit tests, 5 bi-unit tests, 12 single unit tests, and in addition to that you will be getting 16 Sunday tests. So in total you will be getting around 50 tests. So you can enroll for this test series if you are applying, if you are targeting for December 2024 exam. Links are given in the description, and you can also enroll for this course. This course is ongoing currently, complete batch course for the upcoming CSIR-NET, and this will even valid till March 2025. This will also cover your GATE exam and BRC exam as well. And if you want only 100 most important topics, then also you can download our Physics Hub app from the Play Store. You can visit our website www.physicshub.in, or you can contact me on this number 7001439940 if you have any query, doubts regarding this course and everything. So without any further ado, let's start with the first problem. ये problem देखो, this is an easy problem. And if electronic charge E, try to understand this problem. Electronic charge E, electron mass m, speed of light c, Planck's constant h are taken as fundamental quantities. Permeability of the vacuum can be expressed in which units? संडे टेस्ट का सॉल्यूशन चाहिए. हाँ आपने नहीं दिया संडे टेस्ट नेहा? वेबसाइट पे तो अपलोडेड था. हर संडे टेस्ट अपलोड हो जाएंगे. यू कैन गिव इट फ्रॉम देयर. So I think ये वाला question, I think this question all of you must have solved by yourself. Here what is the main problem? The main problem is with this mu naught. What is the dimension of mu naught? If you do not know the dimension of mu naught, you cannot find out. Okay. Now you know an expression that if you have studied electromagnetic theory, what is the force acting between two current carrying wire which are carrying a current, let's say I. So for this current carrying wire, they are following the current in the same direction, so it will be attractive in nature. So what is the force? force per unit length is mu naught I1 I2 by 2 pi d. From this you can get the dimension of mu. L is the dimension of length and d is the dimension of this dimension of length is getting cancelled, and you can say that the dimension of mu naught, it is equals to dimension of f. So m l t to the power minus 2, this is the dimensional formula of force, and I1 I2, these are current. So current is represented by A, two current components are there, so A into A square. Now it is going on the other side, so it will be A to the power minus 2. If you know this, then the remaining thing is simple. So we do not know the dependency of these quantities on mu, so we can write, let's say that mu naught is depending on, k is some proportionality constant, e to the power a, electronic charge ke power a, okay, m to the power b, c to the power c, and Planck constant h to the power d. Now once you calculate a, b, c, d, then you are good to go, your solution is done. Now dimension of mu naught is m l t to the power minus 2 a to the power minus 2. K is dimensionless constant, so we don't need to worry about that. Electronic charge, what is the dimension of electronic charge? Do you know what is the dimension of electronic charge? Which relation you can use? Current equals to dq by dt, so charge equals to I into t, na? So what will be the dimensional formula for E? Current into time, and mass का तो पता है m. C is speed of light, so LT inverse. Remembering class 11 thing, h is the Planck constant. So what is the dimensional formula for h? E equals to h nu formula you can use, है ना? E equals to h nu. So dimension of h is dimension of E divided by nu. What is the dimension of E? ml square t to the power minus 2, and this nu is t inverse. So effectively it becomes ml square t inverse. Got it? Just put the value here, ml square t inverse to the power d. Now you just need to gather the coefficient of m, l, t and a, okay. Hence m, l, t to the power minus 2, a to the power minus 2, this is equals to, first gather the coefficient of m. Here what is m? M to the power b, and one coefficient will come from here, m plus d. L, c है यहाँ पे, c and 2d है ना, c plus 2d. T, a minus c minus d, okay, a minus c minus d, and a to the power, only one component is a to the power a. So the both sides should be equal, है ना. On comparing both sides, we get, what do we get? If you compare both sides, what do you get? A we can easily calculate, a is equals to minus 2, है ना. B plus D equals to 1, this gives you B is equals to minus D. C plus 2D equals to 1, and A minus C minus D is equals to minus 2. A minus C minus D is equals to minus 2. And C plus 2D is equals to 1. Now you can easily solve this. Look, A is equals to minus 2, we have already got, minus C, and D and B are same. So we can put the value of C from here, है ना? Just put the value of C. C is equals to 1 minus 2D. So if you put the value of C here, you get minus 1 minus minus plus 2D minus D equals to minus 2. So here D is equals to how much you are getting? D equals to 1. So once D is equals to 1 means B is equals to minus 1. If B is equals to minus 1, okay, so C you can also calculate. C is equals to minus 1. अच्छा, B प्लस D इज इक्वल्स टू 1. अच्छा, हम लोगों ने गलती कर दिया है. सो B इज इक्वल्स टू, यू सी, 1 माइनस D. A minus C minus D is equals to minus 2. So you can put the values once again. Little bit of mistake we have done. A minus C minus D is equals to minus 2. A is minus 2, है ना, minus C minus D is equals to, okay, C, value of C you put, minus 1 plus 2D minus D is equals to minus 2. From this D is equals to how much? 1. And B is equals to 1 minus 1, so 0. And C is equals to minus 1. So the dimension formula for mu naught becomes, you see, H by C E square. So this is matching with option C, 3. Clear, guys? Let's go to the next problem. Look, I think you have already seen the solution, but so let's move forward quickly. A quantity f is given by this expression. C, G, H are the standard quantities. Dimension of f is that of equal to, dimension of f किसके बराबर होगा? देखो, speed of light, you know the dimension, LT inverse, no issue in this. Gravitational constant, you should remember this, m inverse L cube t to the power minus 2. You can find it out from the Newton's law of gravitation. F is equals to g into m1 m2 by r square. From that you will get this formula, m inverse L cube t to the power minus 2. What remains? H. H, dimensional formula of H we have already written, ml square t inverse. So what is the dimension of f? So it is the dimension of hc to the power 5 by g, correct? So just put the values. root over h is ml square t inverse. अब देखो c to the power 5 means l to the power 5 t to the power minus 5 divided by g m inverse l cube t to the power minus 2. So what you are getting m to the power 2 and root is there, so it will become m. 7 minus 3 4, so l square t to the power minus 6 plus 2 minus 4, so t to the power minus 2. What is the dimension? What is this dimension? ml square t to the power minus 2. This is okay, ml t to the power minus 2 force time length. So work means energy. Energy is there? Yes. Option 2. Is it understood? Okay, this was a good problem. The force interaction between two atoms is given by this expression, where x is the distance, k is the Boltzmann constant, t is the temperature, alpha beta 2 constant. The dimension of beta is how will you solve this? Remember one thing, that exponential terms are dimensionless. This is the thing you need to know. Exponential terms are dimensionless, means the dimension of x square by alpha kt, this should be equals to m to the power 0, l to the power 0, t to the power 0, as they are dimensionless. Fine. So you have to find out a dimension of alpha. Look, dimension of f should be equals to dimension of alpha into dimension of beta, because this exponential term, this is your dimensionless. So from the homogeneity principle, we know dimension on the right hand side and dimension on the left hand side should be equal. So dimension of force will be multiplication of dimension of alpha and beta. So dimension of beta will be dimension of force by dimension of alpha. So we need to first calculate the dimension of alpha, that you can find from here. X square dimension is L square. We do not know the dimension of alpha. Kt, Kt is what? E is equals to Kt. So Kt is nothing but energy. Okay. So you can write ml square t to the power minus 2. This is equals to m to the power 0, l to the power 0, t to the power 0. And from this we can evaluate the expression for alpha. So if you see, what will be the expression of alpha? It will be m inverse t to the power 2. So once you get the dimension of alpha, now dimension of f is equals to dimension of alpha times dimension of beta, and hence dimension of beta is equals to dimension of f divided by dimension of alpha, m l t to the power minus 2 divided by m inverse t square. So this becomes m square l t to the power minus 4. that is matching with option 2. Let's move on to this next question. Consider the vector field V of xyz equals to alpha xyz I cap plus this. The value of A for which V can be written as the gradient of a scalar function is. So, if V is written as, if V can be written as the gradient of a scalar function, what you can write? V can be written as the gradient of a scalar function. Hence, in what condition we can write? If curl of that vector is 0, then only we can write. So let's find out the curl. Curl of this vector will be equals to I cap, j cap, k cap, del del x, del del y, del del z, a times x y z, x square z plus 2y and x square y. Okay, can you write it in this way? So I cap, let's evaluate this. It is x square minus x square, na? X square minus x square. Let's calculate for j cap. It is axy minus 2xy plus the third term k cap. This will be 2xz minus axz. And you see, if this is equals to xy times a minus 2 j cap, the first term is 0 plus xz times 2 minus a k cap. Under what condition this curl of V will be 0? So it will be 0 if this a minus 2 is equals to 0, means if a is equals to 2, then this curl will be 0, and if curl is 0, V can be written as gradient of a scalar function. That is what the question is asking. So option 3 is the correct option for this question, a equals to 2. So this was a simple problem, you just need to have this idea. Now this is a very good problem, you can do it without calculating, or even if you calculate you will get the answer. Without calculation also you can find out the value of the surface integral 1/1/4 a dot n cap ds, where a is this. S is the surface of the unit sphere centered at the origin. First of all, it is a unit sphere, and n cap is the inward normal, not the outward normal. These two things are very crucial. That is why we need to read the question paper very carefully. Generally we see that n cap is directed outward, but here it has specifically mentioned that your n cap is directed inward and the radius is unit radius. Now even without calculation, what does this represent? A dot n cap ds, this is a like area, it represents the area, area of a sphere, so that is 4 pi r square. Now if this sphere is having unit radius, so 4 pi, 1 by 4 of 4 pi is pi, and inward normal, because of that a minus sign will appear, so minus pi. So without calculation we can find out that it is minus pi. Now let's calculate this. Okay, so to do this problem, what can you do? What is the kind of surface it is? This is a sphere, so you know that sphere is a closed surface. So for this closed surface we can use divergence theorem to convert this surface integral into a volume integral. So using divergence theorem, we can write surface integration of A dot n cap ds, this is equals to, you see this n cap is unit inward normal, so we have to take care of that. So I am just writing 1 by 4 was there, minus 1 by 4 integration v curl of A dv, because we need to take outward normal to convert from the surface to volume. Okay, n cap points inward. Now what is divergence of A? Let's calculate it separately. A is this, so divergence of A is equals to del x del y del z. So this is 3. Okay, if this is 3, this becomes minus 1 by 4 into 3 integration of v dv. What is this volume? This is the volume of the sphere. What is this volume? 4/3 pi r cube. 4/3 pi r cube. R is 1 here. So 3 get cancelled, 4 get cancelled, so minus pi. Okay, option 1. Clear? Okay, Harry, we'll upload into the course folder, don't worry. Let's go for the next problem, problem number 6. This is a very good problem. The plane P contains the points A, B and C, which have position vectors A, B, C given respectively. The equation of the plane is, let me show you the situation. Let's say you have a plane like this. Okay, and it contains, let's say, 3 points A, B, C, and the position vectors are given. You have to find out this equation of this plane. This plane is P. Can you do this? Look, A is given to you minus 3 I cap plus 2 j cap, B is given to you 7 I cap plus 2 j cap, and C is given to you 2 I cap plus 3 j cap plus 2 k cap. So from this, now what is the condition of 3 vectors being on the same plane? You know, the scalar triple product is 0 for coplanar vectors. So if I, let's say, take another point, let's say this is the origin. If I take any point R whose coordinate is, let's say, x, y, z. R has a coordinate, say x I cap, y j cap, z k cap. So we can say that all these vectors, whether this vector or this vector or this vector, all of them will be on the same plane. है ना? Just a moment, guys. This mouse shows problem. So what we have done, let us take a point, R whose coordinate is x, y, z on the plane. So if you have taken a point R on the plane, so what will be the value of R minus A? R minus A is the distance between point R and point A. So you know how to calculate this R minus A. You need to take the coefficient difference. So x and A, so x minus 3, x minus of minus 3, so x plus 3 I cap plus y minus 2 j cap plus z minus 0 k cap, so z k cap, because there is no z component of A. Similarly, R minus A is this. Let's take B minus A then. B minus A. So coordinate of B will be subtracted from the coordinates of A. So 7 minus of minus 3 is 10 I cap. You can choose any combination and you can take the scalar triple product. It should come 0 if they are coplanar. C minus A, 2 minus of minus 3, so 5 I cap plus j cap plus 2 k cap. Since these vectors are coplanar, hence the scalar triple product, that is R minus A dot B cross C, B minus A dot B cross C, so C minus A, this should be equals to 0. This is the condition of 3 vectors being on the same plane. So we know the values, just put the values, x plus 3 I cap plus y minus 2 j cap plus z k cap. What will be the value of this product of B minus A cross C minus A? 10 into 5, I cross I, this will be 0, I cross j, देखो I j k. So if you take the cross product of I and j, you get k. So I cross j is k. So 10 k cap. Now 10 into 2, 20 I cap cross k cap. We are coming into the anti-clockwise direction, so it will be minus j cap. So minus 20 j cap, this is equals to 0, and hence what you will get, just take the product 10z, and I know I cap term is there, so 10y, acha, minus 20y minus minus plus 40 plus 10z equals to 0. So if you take 10 common, minus 2y plus z equals to minus 4. Minus 2y plus z equals to minus 4. Is there any option like this? Minus 2y plus z equals to minus 4. Option 3. So look, several problems can be set based on the same logic, but if your main concept is clear that the scalar triple product of three vectors, if they are if it is 0, then all those three vectors will lie on the same plane. This is the main concept being used here. चलो आगे बढ़ते हैं. Let's move on to question number 7. Read this problem and tell me whether you can do it. Consider the vector field given by A. Which of the following statement is incorrect? Means 3 statements are correct, 1 statement is incorrect. Can you do this? Look at the option A dot dl is equals to 0 for any closed contour. As we are seeing A dot dl, immediately it should come into our mind that we should know about curl of A. If curl of A is 0, then we can say that the vector A is conservative. And once we are confirm about A being conservative, we can draw many conclusions. So our first task would be to calculate curl of A. A is given to you, let's calculate curl of A. Given A is equals to, this question paper you can get it on our Telegram channel, you can download the PDF, okay? You don't need to write the questions, you can download the PDFs from the Telegram channel, Physics of 111, the link is given in the pinned comment and description. This is a vector given to you, y square I cap plus 2xy j cap minus z square k cap. Fine. First let's calculate the curl. Curl will be I cap, j cap, k cap, del del x, del del y, del del z, put the value y square, 2xy and minus z square. Just expand this. You see what do you get? I cap, this is 0, j cap 0 0, k cap also 0, y minus y 0, 2y minus 2y 0. So as curl of A equals to 0, therefore we can say that the vector field A is conservative in nature. Now if a vector field is conservative in nature, then the work done by the field, integration A dot dl around any closed loop will be 0. Simple fact, universal truth. So the first statement is true. Scalar potential corresponding to the vector field phi is. Now you know that if the curl of a vector field is 0, so it can be written as the gradient of some scalar. This is also universal truth. Since the vector A, since A is a conservative field, it can be written as the gradient of a scalar, gradient of a scalar potential function, let's name it phi. That is, we can express it in this way: A is equals to grad phi. The way you have seen in electric field is equals to minus grad V, and from this what you can write? We can write it from d phi. This is like grad phi dot dr. Okay. So it is like E equals to, sorry, dv is equals to E dot dl. Grad phi dot dr, what is this thing? Grad phi is A we have already known, dot dr is dx, dr is dx I cap, dy j cap, dz k cap. Grad phi is A is this, so you will have y square dx plus 2xy dy minus z square dz. Now as you can see, we need to express it in the form of d of something, then we can write phi, expression of phi. Yeah. So if I write, let's say d of xy square, so d of xy square means y square dx plus 2xy dy. Okay, the first two terms have been written by this simple expression. Z square dz minus 1/3 d of z cube. D of z cube is 3z square dz, so 3 get cancelled, so we can write it in this way. So combiningly we can write that d of xy square minus z cube by 3, and some constant will appear as an integration constant. As you can see, it is not changing this value, same na, because derivative of a constant, c is a constant, derivative of a constant is 0, so we can add a c, and hence if we compare the both sides, you get phi is equals to xy square minus z cube by 3 plus c. Now look at the options: xy square minus z cube by 3 plus c. It is correct, but here z square by 2, so this option is incorrect, and incorrect option we have to find. So option 2 is the correct option. Let's choose the fourth statement also. Look, for a conservative field, if you take the line integral between 2 points, you know that line integral depends on the 2 points only, not on the path taken to reach that point. Let's say आपके पास, let's say R1 point is there, R2 point is there. If you are taking the line integral, so the path is not important, either you take this path or you take this path or you take this path, all the paths will lead to the same integration, because the line integration depends only on the initial point and the final point. So let's check the last point also. last point R1 to R2 A dot dl. So we can just write A dot dl. We have got phi of R2 minus phi at R1. R2 and R1 is given to you. R2 is given you 2, 1, 0. R1 is given to you 1 root 2 0. Check the coefficient, sorry, coordinate I cap, so 1 root 2, there is no z component, so 0. Here it is 2 I cap, so 2, j cap 1, no k cap, so 0. That is what we have taken, R2, phi at R2 minus phi at R1. So phi value we have calculated here. So if you put x equals to 2, y equals to 1, so you get 2 plus c is cancelling, no worry, x equals to 1, y equals to root 2, again you get 2, so this is 0, and hence the last option is also the statement is correct. So this was a very good problem actually. You need to have a couple of information or knowledge, then you can easily do it. Batao guys, if anyone has any doubt, then we'll go for the 8th problem. This problem is quite easy. For the 3 vectors a, b, c, O being a equals to b cross c, what is the value of this thing? B cross c cross a plus c cross a cross b. This is given to you equals to ma, so you have to find out the value of m. Now you know a very interesting property. If a, b, c 3 vectors we are given, then you, I think, remember this chain rule, a cross b cross c plus, so you have to think it in this way, just take it in a clockwise sense, a cross b cross c plus, then b से शुरू करेंगे, b cross c cross a plus c cross a cross b, this is equals to 0. This is the chain rule we know. You have to find out the value of b cross c cross a, so we can write this b cross c cross a plus c cross a cross b, this is equals to, you see, this will go to the left hand right hand side, minus a cross b cross c. Now a is given to you b cross c, so we can put the value of b cross c as a cross a is 0, so this is equals to m times a. For what value of m this is possible? Obviously m is equals to 0, option A. Few simple questions have been added in a Sunday test so that you don't get demotivated, because this is the starting of the course. So if I give all the difficult questions, then you will be demotivated. That is why I keep mixed questions. Few questions are very difficult, few questions are moderate, few questions are very easy. Like this problem, question number 9 is very easy. If f is equals to y cube x square, what is the value of grad square f? So Laplacian of f you have to find out. Grad square f, you know the formula. This is given in 2D. x and y is given, so this is given in 2D. So your formula will be grad square f by, so del square f by del x square plus del square f by del y square. Okay, so del square f by del x square, if you take derivative 2 times with respect to x, so 2y cube plus, if you take derivative with respect to y, 2 times 3 y square 6y x square, and hence grad square f at 1 2 x equals to 1 y equals to 2, so 2 times 2 cube plus 6 times 2 times 1 square, 16 12 28 3. This was simple question. Now give it a try. This next question on the, okay, so vector problems are done. Now matrix problems. Remaining 6 problems are matrix problems. Given that matrix A, pick out the incorrect statement. So 3 statements are correct, 1 is incorrect. First of all, the determinant of the matrix is A. So one way is that you can calculate the determinant. Okay, but that is not a smart idea. The smart idea is to identify the matrix. The matrix is looking very symmetric, na? Let's check that whether it is symmetric. We have the mathematical tool A transpose you take. If you take A transpose, then what are you getting? Zero minus 1 minus 1 1 0 minus 1 1 1 0. Okay, so if you take transpose, acha, if you take negative 1 common, what do you have? 0 1 1 minus 1 minus 1 0 minus minus plus plus 1 minus 1 0. Acha, so this is your original matrix minus A. So A is square-symmetric, na? Not symmetric, square-symmetric. A is a square-symmetric matrix. For a square-symmetric matrix, you know, the determinant is 0 if the order is odd. So here, what is the order of this matrix? 3. N is equals to 3. So remember this thing, you can utilize this. Note, the determinant of a square-symmetric matrix of odd order, maybe 3 by 3 or 5 by 5, odd order is 0. You can manually calculate the determinant, then also you will get 0. So this statement is correct. The matrix A to the power 18 is symmetric. Now for a square symmetric matrix, you know, another thing, you know, for a square symmetric matrix A to the power n will be symmetric if n is even. and a to the power n will be antisymmetric or skew symmetric if n is odd. So 18 is an even number, so a to the power 18 will be symmetric. So this is also a statement correct. Therefore you can write a to the power 18 is a symmetric matrix. So 2 points we have explored. Let's go for the third point, the eigenvalues of the matrix. Let's calculate the eigenvalue. Eigenvalues we are calculating. If anyone has any doubt, you can ask. Okay, feel free to ask. Minus lambda minus lambda minus lambda minus 1 minus 1 minus 1 plus 1 plus 1 plus 1. This is the characteristic equation. So if you write this characteristic equation, you will get minus lambda times lambda square plus 1 minus lambda plus 1 plus 1 minus lambda equals to 0. So if you simplify a little bit, you will get minus lambda cube minus 3 lambda equals to 0. From this, lambda times lambda square minus 3 equals to 0, and this gives you 3 roots of lambda. First one is 0, second one lambda square is equals to 3. So this will be plus. So plus minus root 3i. But in the option it is plus minus root 2i is given. So this is the incorrect statement. So this is the correct option actually. Let's check this second statement also. Last statement, A transpose square minus A square is a null matrix. देखो, A transpose square minus A square. A transpose you have seen minus A. Minus A square is A square minus A square. So null matrix, na? So fourth of statement is also correct. So option 3 is the correct option. Can you do this problem? This is a very manual problem. Let A equals to this, then smallest positive integers are that A to the power n is equals to I. So there is no other way just other than to check it different powers. A is this. What is the value of A square? 0, 1, minus 1, plus 1. So you will calculate the first few orders, let's say up to 3. Then you will understand whether there is a pattern or not. You will see a pattern 0, minus 1, plus 1, plus 1. So this is 0, minus 1, 0, plus 1, 0, minus 1, minus 1, plus 1. So 0. बाद नहीं बनी, A cube ले लेते हैं. A cube is A square into A. So it is minus 1 plus 1 minus 1 0. A is 0 1 minus 1 plus 1. So 0 0 minus 1 minus 1 plus 1 0 0 0 minus 1. So it is looking like minus of 1 0 0 1. This is identity, minus identity. So if A cube is minus identity, A to the power 6 will be minus identity square. So identity, so value of n is equals to 6. So this type of problem you can do by just evaluating first few orders, and you will get to see a pattern. Once you see the pattern, you can easily evaluate the solution. Let's go for the 12th problem. Which of the following statement is incorrect about the matrix given below? So if you look at this matrix, you can see it is symmetric, orthogonal also. First option is, first statement is correct. X is symmetric, X is orthogonal. So X transpose equals to I, and X is equals to X transpose. So you see X transpose equals to X inverse, and X inverse is equals to X transpose, means X inverse equals to X. All the eigenvalues of matrix X are a real number. So as this is a symmetric matrix, eigenvalue must be real, so this is also correct. X equals to X inverse, this is also correct. Determinant of X inverse is 1. So what is the determinant of X? Determinant of X, as you can see, it is 1, and X equals to X inverse, so determinant of X inverse should also be 1. Sorry, it will be minus 1, no? Minus 1. So determinant of X inverse should also be minus 1, but in the question it is given plus 1. That is why this is an incorrect option and the correct answer. Simple problem, but you need to have some idea. I hope this problem is clear to you. Now a very good problem is there. Let A and B real invertible matrices such that AB is equals to minus BA. Then which of the options is correct? Can you do this? To solve this problem, you need to have a concept called similarity transformation. Similarity transformation. As per this similarity transformation, B, if you can write it as P inverse AP, then we can say that A and B are similar matrices. Now when A and B are similar matrices, they have very interesting property. They have same eigenvalues. Okay, but not necessarily same eigenvectors. Their trace will be same. Traces are same. Eigenvalues are same, so traces will also be same. Now given condition is AB is equals to minus BA. Now we can consider two cases. AB is there. So if AB is equals to, let's say, minus BA is there. You do one thing, just multiply with B inverse. Pre-multiply with B inverse. Pre-multiply both sides with B inverse. what you get? You get B inverse AB is equals to minus A. So what we can say, that A is similar to minus B. Take another case, AB is equals to minus BA is given. Let's post multiply with A inverse. This is post multiplication with A inverse. Post multiply with A inverse. What it generates? AB A inverse is equals to minus B. So we can say B is similar to minus A. As I told you, if A, B are similar matrices, then they have same eigenvalue or same trace. Now you see, A is similar to not B minus B, B is similar to not A but minus A. So what we can write? We can just write it like this, that trace, therefore from this, trace of A is equals to trace of minus B, and trace of B is equals to trace of minus A. When this is possible? This is only possible when trace of A and B are equal and 0. This is a very conceptual problem. Option 1. Acha. Okay, there is a little bit mistake. You see, B is equals to P inverse AP. So A and B are similar. Here B inverse AB is equals to minus A, means A and minus A are similar ना. थोड़ा सा गड़बड़ी हो गया है. So trace of A equals to trace of minus A. Okay. Two more problems from matrices. Let's go to the second last problem, 14. This is based on Cayley-Hamilton theorem. A matrix is given to you, identity matrix I, and you are given 6A inverse is equals to A times A square plus B times A plus C times I. A, B, C are real numbers. What is the value of A, B, C? So obviously from this we can predict that we need to utilize the Cayley-Hamilton theorem. According to Cayley-Hamilton theorem, every square matrices satisfies its own characteristic equation. So characteristic equation of this matrix, let's write A minus lambda I is equals to 0. This is the characteristic equation. So this will be 1 minus lambda minus 2 minus lambda minus 3 minus lambda, and the other elements will remain as it is. This is equals to 0. and we can write that 1 minus lambda, 2 plus lambda, 3 plus lambda, and 0, this term is 0, 2, that is also 0. So only this first term is surviving. So let's multiply 1 minus lambda, 6 plus 2 plus 3, 5 lambda plus lambda square, है ना. Let's once again minus lambda cube, let's calculate this product, lambda cube, 5 lambda square plus lambda square, अच्छा minus 5, so minus 4 minus plus 4 lambda square, 5 lambda minus 6 lambda, so lambda plus 6, so minus 6, है ना. So from this we can write 6 is equals to lambda cube plus 4 lambda square plus lambda. Now this characteristic equation satisfies this characteristic equation is also satisfied by the matrix according to Cayley-Hamilton theorem. So as per the Cayley-Hamilton theorem, we can write 6 is a number, so we have to multiply with identity matrix to make it a matrix. Lambda cube, so a cube, plus 4 lambda square, so a square, plus lambda means a. Okay. Now 6 A inverse is given. How can you get A inverse? If you multiply both sides with A inverse, so this will become 6 A inverse. A cube into A inverse is A square, plus 4 A square into A inverse is A inverse is identity. Now if you just compare, then you can get the values of A, B, C. Compare this equation with this equation and you get A is equals to 1, B is equals to 4, C is equals to 1, 1, 4, 1, option 4. Let's move on to the next question, or this is the last question for this set. If matrix A is given by this, then the smallest eigenvalue of this A square plus e to the power a plus minus I. This is also an application of the Cayley-Hamilton theorem. So we have to find out the characteristic polynomial first. From a minus lambda I is equals to 0, we can calculate the characteristic polynomial for this matrix. Minus lambda, 1 plus I, 0, 1 plus I, 1 minus I, 0, 1 minus I. This equals to 0. Let's calculate this characteristic polynomial. Minus lambda square minus 1 plus I, 1 minus I, so 1 plus 1. Minus 1 plus I minus lambda 1 minus I. From this minus lambda square minus 2 minus plus 2 lambda. This is equals to 0. So lambda cube plus 2 lambda plus 2 lambda. So lambda cube plus 4 lambda. Lambda, अच्छा minus 4 lambda. lambda square minus 4. So what are the eigenvalues we are getting? First eigenvalue we are getting 0, 2 and third one minus 2. So these are the three eigenvalues, a square e to the power a minus I. So these are the eigenvalues of a. So eigenvalues of a is 0, 2, minus 2. So what will be the eigenvalue of a square? You know it very well, square of the eigenvalues. So 0 plus 4 plus 4. Eigenvalue of e to the power a, e to the power 0, 1, e to the power 2, e to the power minus 2. An identity matrix has eigenvalues 1, 1, 1. You have to find out the smallest eigenvalue of this matrix a square plus e to the power a minus I. So obviously you can see the smallest eigenvalue can be framed from the first eigenvalues. Therefore the smallest eigenvalue of a square plus e to the power a minus I. So we will be taking this 0 plus 1 minus 1. So this is 0. This is the smallest eigenvalue that is matching with option 1. So okay guys, in this session we have covered all the 15 problems which we gave in the Sunday test. I hope you find this session useful, and on every Sunday we will be taking this Sunday test and we will also provide the solution. These Sunday tests are part of our test series. In the test series total 50 tests will be there, and out of those 50 tests 16 tests will be Sunday test, which will be uploaded on every Sunday. Other tests are uploaded separately. You can also give, you will be getting 12 full length tests as per the official CSIR-NET pattern. 2 half syllabus tests, half of syllabus will be covered. 3 tri-unit tests, 3 subjects will be taken together in a test. 5 bi-unit tests, bi-unit means 2 subjects will be taken, let's say MMP, classical, EMT, ATMOL, in this way. 12 single unit tests for each subject, you will be getting 12, total 12 single unit tests. In this way total 50 tests you will get. You can join this test series. Try to join this test series from the very beginning so that you can make maximum use of it. There are a lot of questions, okay, that requires time. So you can join it from the link given in the description. This will valid till December exam, and other courses are also going on. This complete batch course is going on. This is taken complete in English language, so you can join this. Just started, we are currently doing mathematical methods. Okay, so with this let's end the session here. Thank you very much for joining this session. If you are new to this channel, please subscribe the channel and don't forget to press the bell icon. And finally, thanks for watching. Everybody like the video.